Today, I will continue to teach Lecture 4, Introduced to Image Processing with MATLAB. Especially, I will teach some basic themes, and also I will give some examples. Let me get the pen. We already talked about the image read and write. Sometimes also we call the read as input and write as export. So if some people talk about input image in MATLAB and export image in MATLAB, that means read and write. In fact, we already talked about you can read different format of images. Also, you can write the image in different format. There are BMP format, GIF format, HDF, JPEG, PCX, PNG, TIFF, XWT. Also, there is another raw data and other types of image data. For example, DICOM. The bunch of data are in MATLAB. Also, sometimes we say this image is BMP image, is GIF image, or JPEG image. Generally, we talk is formats. That's classify the image based on the formats. Also, in MATLAB, sometimes we classify the image based on the data type, the image used to store the image. In order to understand the image types, we also need to understand the data type. You guys know in C, Java, in bunch of language, we always need to define the data type. In MATLAB, we already know the fundamental data type are array or matrix. Besides the fundamental data types, we also have integers, doubles, correct streams, structures, and cell. For image processing, we're more interested in the integer, doubles. The data types supported by MATLAB are classified as follows. We have a bunch of this kind of data type. For double, it's similar to C. In fact, it's 8 bytes per element. For example, for 20, this number, if it's a double, that means we need 8 bytes to store it in MATLAB. That's called double precision. Generally, the double precision can use to represent fraction number. For example, 101 dot something. Okay, that's fraction number. That's double. Also, we have single precision. Single precision save the element by 4 bytes, not 8 bytes. So double is more accurate than single. But both of these two can be used to represent fraction numbers. Besides the double and single, we also have different integer type. For example, unsigned 8-bit integer. Generally, the range is from 0 to 255. Each element for unsigned 8 bits integer will be represented by 1 byte. Besides, also we have unsigned 16-bit integers. The range of the number will be big. And also unsigned 32-bit integers. The range also very big. So you guys see here, this 3 is unsigned. Unsigned means it's non-negative number. Okay, start from 0. You cannot say unsigned 8-bit can be -1. That's when not correct. Besides for the unsigned, we also have signed integer. Okay, we also have 3 types. One is 8 bits. The range will be from -128 to +127. Also, there is a unsigned 16 bits integer in the range from this one to this one. And the signed 32-bit integer in the range this. So when you use this kind of integer to compute, generally we use the signed integers, especially for subtraction, because there is a negative number happen. Definitely, in most cases, we can use double or single to compute the subtraction or something. That will be more accurate. Single and double sometimes also we call it float. If you guys are familiar with Java and C, float are there. Okay. Besides this kind of 3, also we have a char. Char is 2 bytes per element. MATLAB defined a char, okay, for example 2, that will be 2 bytes represent this number. Besides char, we also have logical type. Logic type in C or some other language, which generally means is the true or false. Okay, for example, 1 means true, 0 means false. Each element is represented by 1 byte. Generally speaking, in MATLAB, if you do the numerical computation, we generally use the double precision. Okay. For the unsigned 8, it's generally used for image. We know we have this kind of data type here. So, for example, you have how to convert to double, and you have double, how to convert it. Unsigned 8, that's much easy. You can just use the data class name. For example, you have unsigned A equal to 8. If you want to convert to double, you can let B equal to double. That's data class name, okay? Double, then put A here. Then B will be double, okay? For another case is for A1 equal to dot 10 0. You want to convert A1 to A2 equal to, also you can unsigned int 8, convert to unsigned integer 8 bits, then also use similar way. Then A2 will be unsigned. If A2 is negative 10.0, then you put here. Then you will find A2 will be equal to 0. For all of the negative, when they convert to the unsigned integer, they will become to 0. We already talked about the image can have a color image and monochrome image. That's generally talk about in your daily life. Okay. Also, it's talk about how they display on the screen. But based on the how the image are stored, what kind of data type they used. They can be classified in different types. But this kind of classification, they're only used in MATLAB. It's not generally for image processing. Okay, that's I must emphasize here. Only MATLAB can classify them into this kind of types. In fact, if you see for the binary and gray image, both of them are monochrome image. Okay, a monochrome image also we call the gray image. So binary image, in fact, is a special case of grayscale image. But in MATLAB, because the binary image are stored, only use logical values. Okay, I only have two values, 0 and 1. So generally in MATLAB, we separate them. Okay, that's I told you. So beside the monochrome image, we also have true color image. True color image, in fact, in your daily life, also we call it color image. That's called RGB image. In fact, if you go to deep in image processor, the true color image not just be RGB image. There is possible other type of color image based on the three basic colors. Also, there is some called YUV images, but we will not touch this kind of things. We just talk about RGB image in this course. Both of this type and this type that we already taught, but there is a special another type called indexed image in MATLAB. In fact, indexed image here is not means it's a specific type image in your daily life, just based on how the data is stored in this image. It could be a binary image or gray image, or sometimes it's a color image when you display. The only thing is indexed image, it only has a color map. Okay, that's important. For color map, we already talked about in previous lectures. So let's explain them in details. For binary image, I already talked about it only have two values, 0 and 1. Okay? Generally, 0 means black, 1 means white. But the most important thing is a n by n matrix. For the gray image, also it's n by n matrix. But based on how they're stored, they also have four types here. The first type is called single or double precision gray images. The value in the matrix is from 0 to 1. They could be 0.5, 0.6 or something. For example, for this image, 0.5, 0.01, then 0.7. Okay? Because a matrix is an image I already emphasized many times. 1, 1, 1. So this is a double or single precision gray image. If for the matrix value is an unsigned 8 bits array, that's we call unsigned 8 bits image. The value will be range from 0 to 255. Generally, the gray image is in this type. Also, for some image, they will store the value, use unsigned integer 16 bits. The value will range from 0 to 65,535. That's called on-site 16 bits image. I'm sorry, this should be 32 here, okay? So for on-site, I'm sorry, it should be. Sometimes also there is a negative value, okay? So for integer 16 bits, the value will be ranged from negative to positive. So that's for the gray image. For two color image, okay, two color image, first you need to determine is the two color should be n by 3 matrix. That's first things. After that, they also have 3 type. Also, there is double precision two color image. The RGB value is ranged from 0 to 1. It's similar to each color matrix similar here. Okay, for example, R could be 0.1, 0.2, okay, 0.3, 1 or something. Then G is similar, okay, and B is also similar. Only things they have 3 channel RGB, okay. That's for the double precision. For the on-site 8 bits integer, the RGB value will be ranged from 0 to 255. Also, for the second one, is the image we often meet. Also, they can save it in on-site 16 bits. The value will be very big. Okay, that's for the banner image, gray image, and the two color image. For indexed image, as I told you, it's just with a color map. Okay, first is a m by m numeric matrix, then with color map. For this one, they're similar to the gray and the banner image. Okay, just with a color map. Because as we talked before, any image can be displayed as a gray or monocolor image when you display on screen. Only depend on what kind of color map you use. Okay. The first type is single double precision. The inter value range from 1 to some p. So when they create a color map, start from 1 to then p. Okay, then they will corresponding some 3 values RGB. Okay, for example, 0.1, 0.2, 0.3. That's what we talked about last time. That means we need to find the color based on the index. That means that this matrix is store the index. Okay, based on the index, we found the color. So we call it indexed image. Okay, there are p level index for this one. Okay, also for nautical unsigned 8, unsigned 16 array, the value range from 0 to p minus 1. Okay, also you have a color map there. So you have so many types. How to convert them into different type? For example, I have on-site 8 bits number. How to convert to on-site? Also, you have two color image. How to convert from this type to the second type or to the fourth type? Even sometimes you have a gray image. Okay, how to convert to banner image? You have a two color image. How to convert to a banner image? You have an index image. How to convert to other type? So first, let's talk about convert the image types with different data type. How to convert the image from one type to another type? MATLAB Toolbox provide several functions to do that. For example, if it's not unsigned 8 bits image, you want to convert them to unsigned 8 bits image, we can use this function. I'm sorry. Also, let's get the pen first. Also, if we want to convert other type image into unsigned 16 bits image, you can use this function. If we want to convert other type image into double precision image, you can use this function. I list here the input of the image type and output on the image type. For example, for this function, the input image type can be logical, unsigned 8 bits, unsigned 16 bits, and double. Also for this function, the input can also be logical, unsigned 8 bits, unsigned 16 bits, and double image types. For this function, the input can be logical image type, unsigned 8 bits image type, unsigned 16 bits image type, and double image data types. In fact, I have a website here teach you guys how to use this kind of function exactly, because I don't have enough time to teach them one by one. There are a bunch of this function there, not just the 3. Let's go to the website so I can tell you guys how to use this kind of function. Okay. For example, you can just paste, then open the website. There are a bunch of functions here. First, for the data types conversion, we can use this link. Then you guys see a bunch of functions here. Okay. The first one is converting image to double precision. The second one is converting image to 16-bit signed integers. This one is converting image to Java buffered image. I don't want you guys to go with this one. And also there is a converting image to single precision, converting image to 60-bit unsigned integer, converting image to 8-bit unsigned integer. If you click it, it go to the exact page to teach you how to use this kind of function. For example, if you see this one, you will see convert this image to unsigned 8 bits. Okay, use this one. Also, if the image is indexed, then you put the index here. Okay, they will be explain this kind of things here. Also, they give some example here. So this generally used for the image type conversion inside the gray image, or inside a color image, or inside a binary image. Okay. Also, you can convert a gray image to an index image to gray image, index image to RGB image. Also, RGB image to gray image, RGB image to index image. The tool here, the tool here means TO. Okay, that's MATLAB when they write the function. For convenience, they just use the number to represent the tool. Okay. Also, we have a mat to gray. Mat to gray, that means you have a data matrix. Okay, you can convert the data matrix to grayscale image. Okay, then just scale the data. For the specific use, also you can go to the MATLAB website. The link I did not remove, so you just click here. They will automatically come to the the website. So you will find they have some examples here. Then you just learn them one by one, because for this one it's just very basic stuff. Also, it's easy for you to understand. Okay. Also, you can convert the gray and color images to banner image. For example, they use image to BW called image to banner image. Okay. Also, we have three cases. For example, you guys see this I, that's the matrix or image matrix. The level, that means use the threshold. Threshold means, for example, in the image, there are different value there. If I put some level there, that means if the pixel value is more than level, they will convert it to be 1. If the pixel value is less than level, they will convert it to 0. Okay? Generally, the level value will be from 0 to 1. Also, the second type, that means that level and x are the same, only it has a C map. Okay, that means especially you have matrix, then you have a color map, then you put a color map here, especially for the indexed image. Okay, so you do some conversion. If it's an RGB image, also you can do the conversion. Use level here. Okay. So that's convert a gray and color image to binary image. Let's talk some example. First example, I want to use the image called Apple JPG. So first, let's review the image read and write. We can use the image read to read the pixel value of the Apple image to the image matrix. So you will find this image matrix should be n by m by 3. That means this is a true color image. Okay, I remember we can use size to find the dimension here. Okay, also you can, from the workspace, you can find the dimension there. After that, we use figure to create a figure. Then use the image show to show the image here. After that, you can write the image, use the BMP format. See guys, here original format JPG, but I will write to BMP format. In fact, you guys can use bunch of format we talk about here: BMP, GIF, HDF, PCX, and so on. Okay, just you specify the format here. Sometimes even you don't specify the format here, but you write the correct extension here. For example, you put a BMP here. Even you don't put a BMP here, they still create a BMP. But you put a BMP here, even here you don't need the BMP. The result is still a BMP format image. Okay, that's I just review how to use the image read, image show, and image write. Now let's do some conversion. I just want to emphasize these two themes here, because other themes perhaps we will not use in our course. First is the RGB image to gray image. Okay, you can write the code as this one. First, read the Apple JPG into the matrix I. Then use the RGB to gray function to convert this color image to gray image J. If you guys see here, okay, the I originally is m by 3 is a two color image, but after we do the conversion to the J here is m by m matrix, that two dimensional on side 8 bits integer. image. So that's the J. Okay. If you show I and J, I will be like this one. J will be shown like this one. This is a gray image. Okay. After we get the gray image, we can use the image to BW to convert this image to a binary image. Okay. Then see here, K equal image to BW. Then J put here. After that, you get the K. See here, K they tell you is a logical values. That means the value is 0 or 1. Then also you can show K here. Okay, then you found just two values. One is 0, one is 1. So just tell you guys how to use this kind of function here. For other functions, I already tell you guys you need to go to this website to learn them one by one. Okay, I plan to put this as a homework. Then for each case, I hope you guys can run one image to test them.